Now, in a moment, I'm going to turn the presentation over to our presenter, Dan Horon. Dan is presenting on Class N networks, very interesting presentation. But give me a moment. I will turn it over to Dan in 1 second. So you take it away, Dan. It's all you.
Okay.
Thanks.
All right. I want to talk about Class N, as you know, and I have a PowerPoint presentation here, which is only my opinions. I'm on the NFPA Technical Committee for Protected Premises since 2001. I've been on that committee, but my role there is as a volunteer, so I don't represent NFPA in any way, or AFAA for that matter. One of the main things that is going to be clear, and I'm going to go into some detail about, is that the fire alarm industry, as you all know, requires supervision of the circuits. And as far as I know, and I'd like to hear from anybody that's listening, if you know of any other industry that actually has a set of documented rules like the NFPA 72 has for how you're supposed to monitor and what should be monitored in a different system. When I imagine factory floors and HVAC and most IT departments, they like redundancy and they do a lot, but as far as I know, fire alarm is the only industry where their equipment is required to report a fault of itself within 200 seconds. So here we have how that used to be identified in the code. Some of you as old as me will remember the style tables, but this was trying to describe the faults that could occur and designate a style Class A and B is what that never went away, the Class A and B. So when it was our job to get rid of the style tables for the 2010 edition and make a new chapter called Circuits and Pathways, we decided that Class A and B had never gone away. So let's just build on that concept and describe what we want to see in the circuit. At that time in 2010, it was a simple thing. Class B was a pathway that did not have a redundant path, and then conditions that affected the intended path would be enunciated. And that's the supervision that we're talking about. So it seemed pretty simple, and it seemed to describe everything, except that when we came back the next cycle, through the course of the 3 years involved, we added back in some more requirements, and that was that the operational capability is maintained during a single ground fault. So that basically made it so that Ethernet could not work. So because of that, those two requirements made it so that you couldn't take a piece of equipment to UL without modifying it physically and get it UL recognized. UL couldn't test it because, as I'm going to show you, Ethernet handles grounds in a different way. So it's worth noting, though, that wireless and fiber obviously were exempted from reporting the ground because their pathways are through the air or through the fiber. So I'm going to take a minute here and just go back to what I'm going to go pretty fast through this part because all of you I know are well versed with Class A and B circuits. But I wanted to point out that a little bit of history here. What happened after that 2013 was added back in to report a ground, since it made Ethernet no longer compatible. The Technical Correlating Committee of NFPA 72 said we have to figure out a way to get Ethernet in NFPA 72. We have to figure out how to define it, I think even said something to the effect that I don't care if you have to encase conduit in 2 feet of concrete, we're going to have Ethernet in the code one way, shape, or form. So we started these task group meetings, about a dozen of us, and half were fire alarm guys and half were like IT people and people that had networks that they've been using Ethernet and airports or big sites, and they had an interest and some knowledge, and so we got together, the dozen of us, to try to define how to use Ethernet. Well, there was this one discussion that came up about ground faults that over the course of an hour, we'd all remind each other, what was important to our interest groups, to our experience, to our knowledge, and we would share this information. And then 2 weeks later, it seems like everybody forgot what we talked about. So after a few times of this, I spent the weekend making this PowerPoint so that I could show the IT people what we're trying to accomplish in fire alarm. And I could then show the fire alarm guys what the IT people are used to, what they're capable of, and how the circuits are different. So this PowerPoint was actually, from this point on, created to illustrate to both sides what's happening and why it's important. So here we've got a typical Class B pathway, and you monitor the integrity of that with an end-of-line resistor, the old days, the old IDC circuits. Again, I'm showing my age, but I remember designing a lot of systems like that. So it also has to report a short because nothing will work. If you're going to short it, then it would blow fuses in the panel and whatever. So if an open occurs, in the old days it would have been unplugging, unscrewing a smoke detector from a base would open the rest of the circuit. And again, I was showing the IT guys what we find acceptable and what we don't find acceptable as far as monitoring. So along the lines, it became important that a single wire touching ground was halfway to a failure. And the reason that that was halfway to a failure is that if the other leg touches ground, then you get a short through that ground. And keep in mind that these wires I'm showing on this bottom here, as well as the top, could be the same, say, the same pair of wires, albeit with wire nuts and whatever, but the same pair of wires was literally touching, many, many points and had many junctions that where a wire nut could come off and touch ground. So it was very important and very likely that these two legs could someday be shorted. So that is what you're all familiar with. But this is another point that I want to make here, is that all of this is reporting that the devices, the wiring to the devices is intact. We still don't require the individual components to report back that, hey, I'm okay, I'm working fine, which would be possible in today's new SLC technology. That is what we do. But still to this day, NFPA 72 doesn't say that the device has to report back that it's functioning, which is just an interesting side note, because ideally, if we were going to start over today and start writing the code, we'd probably put that in. Say, well, we want to have that all the devices report in constantly. So with the SLCs, as I said, all the devices will report in their little ID numbers. And if for some reason there's an open and it can't see those extra numbers, now we have, again, this communication method. And we're using the fact that we can't talk to the device to indicate that there's a trouble, but we're really still talking about the wires. So it's also important that two wires on the circuit or a short. Okay. So a short also has to be reported, but that would take out the whole circuit in IDC, as you can see. And again, since all these things are directly wired together, the same conductor is going from the panel all the way throughout the whole building and to touch every device, the likelihood of grounds are high. So with IT, I'm drawing it like this to show this is the pathway segment, is what I'm going to call it here. And there's one thing to point out, and this to avoid confusion for me at least in my mind and other people I've talked to think in terms of that there are endpoints. So there is either the origin or the final destination of equipment. We can call those endpoints. And because we don't really care how it gets there, but we want the panel to be able to communicate to the devices in the right way. So now I'm going to talk about how Ethernet wiring is, how it works. And this is the part where I was showing the IT guys, the other IT guys on this committee task group, what we're doing with Ethernet, because it's not how you would expect. It's not what it looks like. When you see a network switch, so we've also maybe seen rows and racks of them. On TV, we've seen tons of all these connectors and all these cables plugged into it. Well, what is not immediately apparent is that every single one of those plugs, even if they're all in a row like that, or whether it's on your laptop, actually has been required by IEEE to be isolated from ground so that the grounds won't go through a cable into equipment and affect other systems and other cables. So they basically had us isolate the connector. And then there's another thing that happens is that these little dots here that I'm showing for transmit and receive data, they're little packets of information. And the packet has its own error checking mechanism so that when it gets to another device from every single cable in an Ethernet network, when it gets to the next device, that device is double checking to make sure the packets are all intact. So you've probably heard the term losing packets. Well, that's because the wiring is either maybe long or there's some other reason. Interference is basically allowable on Ethernet and expected. So what they do is they figure that you're getting a lot of packet loss when these packets keep having to retry a lot, and the receiving end says, "Hey, I didn't get that last thing. Send your packet." So that's what's happening with these packets on every single cable to every single endpoint. It's got its built-in isolation, and it's literally checking to make sure that for that segment the packet is intact, and then it will forward it to other, like through the switch, and go to other computer devices. And I'm sure you've all experienced, especially through these times, your internet may be slow because all of a sudden more people are in your neighborhood using it during the day, and so that's causes a lot of these packets to have to be resent. What slows it down. So like any electrical circuit, if you short the plus and minus, you're going to stop the circuit. It's going to short the circuit. So obviously you're not transmitting data here out through these wires. Nothing's happening. So that's something we would want to predict. Again, the other side could say, hey, I'm not seeing any, I mean, the panel side could know that, hey, I'm not talking to that endpoint anymore. But we're focusing on the short here because this was the reason that they added those 2 extra sections in the 2013 edition. Is what if you get a short on these wires out of a Cat5 cable? One short, just the mindset of a lot of people involved was that, hey, that one short is really important because it predicts that there could be a problem. And yes, in fact, there could be a problem, a lack of communication, where that first short now is stopping the communication. So that was the rub, basically. That's why you couldn't take a piece of equipment from any other manufacturer, Cisco or whatever, and try to take it to UL and say, I want this UL 864 listed, because it didn't report those single grounds. And the reason it didn't report them is that they don't affect anything. A single ground on here has everything still working. So anyway, now we have our packets, and we're traveling across these wires. Packets are going back and forth. At every end of every cable, they're being verified that they're still good, and they're isolated from ground, so we have a good communication. Of course, you could get these 2 grounds here, and nothing happens. It doesn't matter if it's on this other segment, as long as it doesn't short out that same plus and minus. It doesn't even affect anything. So the vulnerability is that if you lose a path, now all of a sudden your 2 endpoints are not talking to each other. And that was what we wanted to get around. So we said, okay, let's use what we know from Class A and Class X, and let's say we're going to make it so that even if there's one fault somewhere, you can still get from endpoint to endpoint. That was with the beginning of us finally coming to a resolution and thinking of a way that would work for both industry sides, the fire alarm and the IT group with Ethernet devices that are already talking to all kinds of things and out there that we all know. So how does that integrate into fire? Well, network people are very used to running redundant cables. I've seen it many times. Just pull 2 in case one is bad. It's just kind of a standard practice. So it's not really that big of a deal for IT people to think in terms of a redundant pathway. And again, all these the Ethernet experts that were on the task group meeting agreed with that. That hey, we can do redundancy. That's a good idea. So just a little recap here. Put it into words. Any segment of a path to more than one field device must be redundant on Class N. And then single paths can be used, but only when it's going to affect a single device. So as long as you are only going to have one device impacted, it's okay to have a single run to that one device. And this is the way it looks. I think it's still the same exact way it was, but when it was first introduced in 2016, it read like this, and it just basically said that 2 or more pathways to everything except the last device, so that only one device is allowed to have basically a branch off to it. In networking terms, I'm sure you've heard the term network drop. So I've talked to different IT departments, when I say this to them, they nod and they understand. They say we're gonna make it a redundant backbone, and we're gonna allow single network drops. That would be basically the whole instruction right there, because like I said, IT folks seem to know what to do with that. So redundant backbone with single network drops. So it was added in 2016, and we spent a long time making what is now the annex. It has a lot of information in it about trying to describe what we're talking about. So the annex, I think it's about 6 pages long, and it's definitely worth putting your attention on. It has a lot of network diagrams, and you'll see that these are not exactly like they were in the code book, but that's because I did them in AutoCAD first, and then NFPA took my drawings from AutoCAD and put them in the book, and then they said I can use them for my own purposes. So I do have permission to show these. This is kind of an interesting one here, where the question came up like from a mass notification company. Can they have their racks of amps? What do they have to do to install those? So here we're showing, it's always been in the code. I hope you can see my cursor here. I think I might be able to put a pointer in there here, like that laser pointer. Okay, so here we're showing 20 feet is allowed between the panel and the first thing, because actually we've never required supervision. Well, not never. At some point in the past, a while ago, it was put in there that it's allowable to go 20 feet of unsupervised wire in the same raceway or enclosure environment, and that was so that different modules and things could be interconnected. And some big systems have multiple cabinets, of course, and so you've got lots of reasons why you might want to allow 20 feet of wiring to exist without monitoring itself. So we said, okay, it's okay to not report a ground within this first chunk coming out of the panel. Now we want redundancy. We want to be able to go to the next switch, knowing we have 2 paths. And then once we're in that enclosure, again, we can interconnect stuff all we want to within 20 feet. And again, not report a ground on this particular cable, and not worry about whether or not it's got multiple devices beyond it, because really we're protecting this arguably at least as well as you would Class B. And that kind of came up during the discussions back and forth, where it's easy to talk about this is a life safety system. We need to put all of our best efforts. We need to do what's best for the system and monitor, and we can't just let the stuff that doesn't report grounds part of our fire alarm system. Kind of the discussion and it was important that we allow Class B. We allow a single path. Remember in the beginning I showed you unscrew one smoke detector, could be 20 detectors after that, all just went offline. That's okay, according to the way codes have been traditionally for decades. The idea is to monitor normal things, the normal environment, to make sure that the normal environment is not changed. And if it does change, we want to report a trouble. So here you have the interconnection between panels is also defined as an SLC. Personally, I kind of made a push to come up with its own. Instead of a signaling line circuit, I would have liked to see a communication line circuit, which is meant that this is between panels, because I think sometimes you would want to do it differently interconnecting between panels than you would from panels to the actual devices on the SLC loop, the field loop. So what I mean by that is that maybe none of these, if each one of these 3 panels I'm showing on this diagram are only in their own building, they're completely, they function as a standalone panel, but you just want to group them together in some way so that you can get information from one building to another just because it's nice, but it's not actually critical to response or the use of the system. So in my mind, you ought to be able to let some of these lines be single in case you have to tunnel through under a parking lot or something to get between buildings, and it makes it not even feasible to try to interlink them. But say you could put a line of sight wireless connection between the two and really accomplish the connection in a different way, but get the job done. Whereas, like I said, otherwise maybe it'd just be cost prohibitive to even do it. So my personal opinion was kind of about allowing, but relying on engineers to specify what was required in each case. On that note, even going back to class A and B, C, we added C, D, and E, and now we have class N. In my opinion, I think it would be appropriate for sometimes engineers to specify that, well, this part we want to be class A, this part we want, and then, for other reasons, because of the physical environment, we want this other area to be, we'll allow it to be class B, or maybe even class C, which was class C is where they just they would report a loss of communication to the other points that they're supposed to monitor, but we don't really specify how they're doing it. In other words, we could rely on these 3 panels all reporting that they see each other, and with one line in between, that would be a class C, but so far I'm not sure it's ever used that way, but that was kind of the intent of these pathway segments, and we do try to term them as segments in the code so that you don't, I'm sure you've probably all been involved in jobs where you're trying to do it, class A, and you just can't, in some cases, accomplish everything that wants to be done. Maybe you're trying to add some equipment and it doesn't have a class A capability. So anyway, I know we have a lot of time left. So I think I'm going to be able to get to some questions. So Perrette, I hope you could email those to me pretty soon.
Okay, yes, I haven't gotten any thus far, so if you want to submit questions, that'd be great.
Yeah, everybody ask questions. Here's another example that's in the code here, where what we're talking about is that imagine this would be very much like a class A loop here, where you're talking to all these devices through this path, and this is just sitting there monitoring itself. But then if it had to, it could switch to this other method. Like if this switch goes bad or a cable gets broken, the idea is that then the other path could be the redundant aspect. So this is also allowed. And again, we're trying to show that we allow things. So besides the ground fault reporting, the other big issue with networks was, well, everybody's going to start tying the fire alarm into their building network, and we just can't allow that lack of control, lack of supervision on the system. Things could go wrong. So what we did is we defined shared pathway designations. They go from 0 up to 3. And there are several things we're doing that right now where we have levels. And level 0 means usually don't worry about it. So here, level 0 means you don't have to take any special care make sure that part of the network is segregated from the other. I can't imagine why anybody would specify that, but it would be a way to say, well, the shared pathway level 0 would be another way to say, we don't need you to think about it for this particular path segment. So then shared pathway level 1. Here we're going to segregate life safety from non-life safety, and then have a way to prioritize life safety data over non-life safety data. So that would be, probably up to equipment manufacturers and installers. It gives a path to say, okay, this is what would be important if you're going to share a little bit. You'd have to still prioritize that the life safety data will work. And then level 2, you can use the same physical wiring, but all life safety data is separate from the non-life safety. And then we have a shared pathway level 3. Again, might be the extreme, but you can imagine an Ethernet network where all switches, all cables, all power supplies, everything is completely dedicated to the fire alarm system or to the life safety system. So
I have some questions. Do you want me to jump in or do you want me to wait?
Let's go with a question. I'll kind of figure out where people are at with the question.
Okay. So here's one. What are the backup power requirements for the network switches?
Good. Good question. Been discussed a lot. And basically, if you're going to have a life safety dependent, you're going to have to, the performance has to be the same as it would for the fire alarm panel itself. Again, this is if it's critical part of the fire alarm system, and it's critical communication goes to us through a switch. You're going to have the same amount of backup power requirements. If a generator is allowed, then the generator could be it. Although even a short blip could sometimes make network devices lose their connection, so you'd have to have a UPS to really maintain it well. But what usually happens, and I don't remember off the top of my head what it is, but I know Chapter 10 has a section on power supplies, and throughout the code you'll find where it says to refer back to Section 10 dot something. I think one of the other numbers is a 4, but you'll refer back to the normal requirements for any fire alarm equipment. So good question.
Okay. Do you want to go for another question?
Sure.
Okay.
Sure.
Okay. Next question. Do the separate paths connecting switches together need to be separated? What would be the spacing if so, meaning horizontal, vertical?
Yes, also a good question and has come up and had many discussions about it. The way it is as of the latest edition, in 2016, to be honest with you, it did not say you had to separate it like that. And part of the reason was because we're just trying to create the minimum for how you would install a Class N. So if we're going to allow Class B, then, all we're doing is, worried about a ground fault is the only reason we're calling out this redundancy in the first place. So it would be, add extra requirement to say that you have to physically put them 7 to 10 feet apart. Or I think it's 10 feet apart now. So anyway, 2016 said you don't have to, and somewhere in the annex, it had a clarification line that says you don't have to have them physically separated. Well, that was changed in the next edition. So 2019 edition, you have to have it. It's the same rule that you would for a Class A or X system on that separation.
Okay, let's go back to the presentation, finish that out because the questions are coming in and then I can feed them to you if we have time.
All right, so here, yep, so in chapter 23, this is where, you know, they talk about different, the SLC circuit basically. So it's other sections that point to these other requirements that were in chapter 12 that said, and so here it says that class N used for the equivalent of the SLC between your panel and your devices, that has to use level 3. So that has to be dedicated to fire system, that wiring. And then level 1 and 2 are permitted. And by the way, level 3, that's the same as today, you know, just all the wiring is for the fire alarm and that's it. So level 1 and 2, you have to have a deployment plan if you're going to begin to share. This is another whole new section, part of NFPA 72, and the annexes where a lot of it, this is in the body of the code here, where you have to have a deployment plan, you have to have a group of people, a team of all the stakeholders that will have to have regular meetings to maintain the system over time. So again, this is for like a major hospital, an airport, a place where they have multiple stakeholders, and you know, building, you know, area occupants and network IT managers, the fire alarm safety people, maybe an HJ in some cases, but you're going to have some people who would care if the fire alarm didn't work, and so they're going to have to be involved in this task group that manages the site and makes sure that, like a change control plan, you have to document, you know, if we decide we're going to change out a switch, who does what? And it's all to make sure the system is reliable and comes back up. So it would be you know, it would be more than any average, you know, little mom and pop store would want to put into their fire alarm system, but it's for the big sites. They'll have a task group. It's also worth pointing out that this is not required for supplemental functions, for ancillary functions. So it says in the code that is not required, class N is not required for supplemental reporting. And there's a figure in there for that. And that's this figure. Again, I have to admit, I made this drawing too, and it's a little bit different in the code, but this is the standard diagram that I have of what I do at CAD Graphics. We make software that works on the PCs, monitors all the different kinds of panels on the market, which is a way to say during these times, if somebody wanted to be able to monitor their panels from home but not interfere with the way it gets reported to the fire department, they just want to, before a security guard calls and says, hey, I got a problem here, they will have wanted to see that and get the notice separately. So, and it's worth noting that one of the major advantages of IT is that now an IP address is like a physical location in the sense that that's the end point of connection. So any endpoints, as you've, I'm sure all noticed, you know, can be taken anywhere, but if they have the IP address and they can be routed through whatever network they're connected to, then it doesn't matter where you are. So because it's kind of like your phones, you dial up a phone number, the person picks up no matter where they are. this non-locality concept is now possible because of Ethernet has the equipment to be able to do it, where you can be redundant and you can locate information in other places that you can't necessarily drag wires to from point A to point B. So it says even that it shall be required to provide supplementary transmission. And we're going to meet again in June, just like this meeting. We're going to all meet from our homes or wherever we happen to be, and we'll cover the next section of public comments for modifications to NFPA 72, and then another hint is that there's going to be a new chapter 11 called cybersecurity. And this is now that we've opened the door for Ethernet, now we are exposing ourselves to a lot of hopefully good ideas. It's just got to all be taken care of with the same kind of caution and mindset that the fire alarm industry has always been able to have, in part because of the code book. Everybody can be on the same page. And again, like I said at the very beginning, that's really rare among industries to have something so well documented and understood by all the different players. So, more questions?
Sure. I have more questions for you. All right. Let's see. Are there any fire alarm systems where the devices are IP as opposed to analog addressable like now?
Not yet, but I can tell you that an individual is pretty in tune with the management at System Sensor is very, very excited about this, and has been since since we started. But now that we got it in, we have some parameters that are well defined, actionable. I know System Sensor is very excited about it. And other than that, when I took my software through UL, there was a device that takes the serial data, the RS-232 data from the panel, and puts it on an IT network. And I'm working with basically 2 companies right now with that, the idea of having those listed. As far as right now, no smoke detectors that I know of are IT, but not I should say that I know of in the commercial industry. Of course, you can go to Home Depot and get one. But
Okay, so another subject is to talk about the Cat5 cable as it applies to fire alarm systems and its listing, as well as the NFPA's take on that. Is there a Cat5 fire alarm listed cable?
as far as I know, there is not yet, but I know the wiring manufacturers have been talking about it for, this 2016 was kind of a beginning point where, companies that make cable finally were able to say, yep, now we have to make it. And, up till then, we were kind of kicking the can down the road, and everybody felt safe that, well, for the next 3 years at least, nobody's going to be needing my fire alarm rated Ethernet cable.
Right. Okay. All right. Let's keep going. I have a few more if we can go.
Sure.
If you are using a dedicated switch for life safety, is there a separate UL and in parens it has NRTL listing for the equipment?
It should be like any other fire alarm equipment, the panel itself and the smoke detectors themselves. Again, these listings go back to compatibility. It's for AHJs that are in a position where you've got an end user, they want to do this new really cool function, but it's requiring this switch, and there is no such thing as a UL864 switch today. I think a couple manufacturers might have them. They wouldn't be, the latest capabilities that you'd get if you went to the open market. So you could probably get a better functional router from the open market. But as far as I know, there still are none that are UL864. But what you can, talk about this. So it'd be up to the AHJ, frankly, to say, well, we're going to allow this, and then they could kick them back to that change plan task group that's got to include the stakeholders and everybody has to make sure it's going to work right. And from a practical perspective, I think that's going to be more important than the actual UL listing on the device. There is movement. I'll have to add this. There's a movement to allow things like computers and printers to be, as long as they're UL listed for their function, in other words, they're shock tolerant and they're not going to cause a fire, those standard types of listings will apply if it's being used for its intended purpose.
Okay. Another question, do the network switches need to be dedicated, as another person asked, or can the switches be shared with other systems? That might be.
That would be how it's defined by, I'm going to go back on the slide for that one. This shared pathway talks directly to that. That's what this is all about. There are actually layers within the topic. So the idea is that if the ideal thing would be all this life safety is all dedicated together, and we don't have to worry about any sharing of any type. But that's not practical. So when you start sharing, what I think we have in there, at least it was discussed, that you should have to plug, I think it is in the annex now, that say you have a network switch and it's got some fire alarm stuff on it and it's got some other stuff on it, and you've designated certain sections for the fire alarm, like within the a managed router, you can have defined that a certain number of ports are dedicated to the fire alarm life safety system because you've prioritized them, you've done this work. You're supposed to plug the other ones and label them or put a tag on them that says do not use for life safety purposes. So you can label it like that if you've designed your network so that you're going to say, okay, ports 1 through 8 are going to be used for fire alarm. We're going to give those priority. Ports 9 through 16 are, for other people to use for their office network. Where you have to make sure you're dedicated so nobody plugs into those other ports that you've designated as being for. And the word port is actually, I don't want to make confusing. There's something, there's a physical plug, and that's what I'm calling port right now. But within life safety, there's kind of a pseudo port also, within Ethernet. And it's a bigger topic, but you could kind of think of an IP address as like your whole TV has an IP address, but it's capable of all these different channels, and each one would be showing its own show. Well, in Ethernet, each IP address has 14,000 separate channel, or 64,000 channels that could each carry their own information. So there could be conversations talking about one thing happening within different ports. Like, for example, internet traffic is always port 80. if a network wants to block everybody from using the internet, they block port 80 from happening. Now nobody can get on the internet. So this port is a very important thing. I'd like to call it a channel, and unfortunately the IT department calls it a port, and that's not to be confused with a physical plug. But again, to answer the original question about sharing the network, it's going to have to be managed, and it's going to have to be labeled, and you're going to have to do your best to make sure nobody comes in and plugs in something that's going to take down the life safety system.
Okay, I have another question. Will the Ethernet fire alarm system require cybersecurity engineers?
Hopefully there'd be no new complex engineering people required. We're trying to, I'd like to see the code, and I always do my best to make the code be as plain English and as easy to understand as possible. On the other hand, we're about to create a new chapter called cybersecurity. This chapter 11 is going to be written for the next edition, and frankly, I haven't seen any of it yet. I haven't seen yet what they're proposing. We're going to have a meeting in June to discuss it, but hopefully, no, you're not going to need special cybersecurity experts.
Okay, I think that wraps up all the bigger question issues that I received.
Okay.
John, do you have anything that you want to add, comments?
Yeah, I had sent a few questions in. What's the fire rating requirements for the redundant pathways, as well as the fire rating requirements between the endpoint and the network switch?
As far as fire rating, the cable itself, as far as I know, there's not such a thing as fire rated Ethernet cable yet, but I have heard different cable manufacturers were talking about it. Like last year at the AFAA show in Orlando, I remember hearing manufacturers talking about it. So it may be available now, but it's important to this is a time of transition here where we had to put something in writing to tell the manufacturers and of cable and equipment to go ahead and start making stuff with Ethernet capability and make it suitable for fire alarm and life safety. And so that got the wheels kind of churning a little bit back then to get so that people will make cable. So today, you're going to have to do an assessment to decide if in this situation, and for an AHJ, I would think that you could kind of, go by your gut and look at the people you're dealing with and think, are these people that are doing their best to make a good system? And you're going to kind of have to rely on that a little bit.
Okay. There's a couple of other questions I'm sure are going to come in. What we will do is we will collect those questions and we will start putting together any type of list that you can to get them out to Dan, and then we'll share all the questions and answers, as I said earlier, with everyone.
Yep. And then, anyone who wants to email me personally, feel free. I like to give advice and talk. So, also next month on June 11th, I'm going to give another talk with AFAA, out of the main office in Ohio, is hosting a webinar. And in that one, I'm going to cover Class N, but also talk about how to connect panels and do that kind of thing. I think a lot of people are asking about that right now, to be able to supplementary monitor their system from home or wherever they happen to be. So that'll be June 11th. I'm going to be talking about that.
Okay. If there are no more questions, we'd like to thank Dan for his time and the presentation, very informative. We'll be in touch, and for certain, we normally have a plaque or something for the presenter, but we'll have to send you a virtual, we'll have to send it in the mail.
Yeah, yes, that's great. That's great. Happy to get it.
But thank you.
I was happy to do the presentation. I really appreciate everybody's time and interest in this topic.
Thank you much.
Yep, thank you.
Anything from anyone else?
Nope.
Nope.
Okay.
But I tell you something, that IP should be a static IP, not dynamic.
Yeah, that's right. Static IP should, use static IPs. Well, for the endpoint.
That's for sure. Okay, thanks, guys.
Thank you.
Everybody stay well, stay healthy.
You're welcome, you too, man. God bless.